Hi everyone, in this video we are going to distinguish a fat from an oil. And so if you recall, this is our third tier of our classification. So the first classification, or a global term, are called lipids. So if you recall, lipids are essentially anything that contains a fatty acid that is insoluble in water. After a lipid, we can break a lipid down into something that is called a triglyceride. So we know in order to create a triglyceride, we need 3 fatty acids. We treat that with a glycerol and we're able to create 1 triglyceride. 1 triglyceride must have 3 ester groups on there in order for it to be considered a triglyceride. Now what we're going to do in this video is break our triglycerides apart into fats and oils, and we're going to try to classify them into even more detailed terms than that, okay? So the first thing we want to do is start off with a very, very simple definition of the difference between a fat and an oil. So we're going to start off by just identifying the physical properties, so it's easiest for a human being to identify the difference between the two. So the first one, let's look at fats. Fats are triglycerides. Triglycerides that are solid at room temperature. Okay, solid at room temperature, RT room temperature. Now, if you recall, room temperature is 25 degrees Celsius. Hopefully you already have that solidified in your brain, but if it's somehow seeped out, that's okay. Just bring it right back in because you need to know it now. Now, a difference would be oils. Okay, so if we're going to compare something from fats, it's going to be oils. Now, oils are going to be your triglycerides that are liquid at room temperature. Liquid at room temperature. Again, so at 25 degrees Celsius, they are liquid. Now, that is the physical property. That is not a real chemical definition or what the difference is between the two. So if you really wanted to get into the nitty-gritty of it, we would actually look at the composition of the triglyceride. So we want to know, what is its chemical formula? What does it actually look like? Okay, so the composition of the triglyceride. And so what we can do here is break this into 2 different categories. We either have something that is called saturated or unsaturated. So let's look at saturated first. So if you hear that you have a saturated fat, for example, what that means is that you have all carbon-carbon but single bonds in the fatty acid. So I'm going to keep reminding you of this, so I'm going to sound like a broken record, but your fatty acid, you need 3 fatty acids in order to create your triglyceride. And if you recall, your fatty acid is that very, very long hydrocarbon chain that has that carboxylic acid at the very, very end. So hydrocarbon chain, carboxylic at the very end. You need 3 of those. You treat it with a glycerol to create your triglyceride. So now, in our fatty acid, if all of them are carbon-carbon single bonds, that is considered saturated. We identify it with the word saturated. Now, the opposite of that would be something that is unsaturated. So in an unsaturated fat or oil, for this example, we would say that it has at least 1 carbon-carbon double bond in the fatty acid. Okay? But we don't stop there. We can actually break apart the unsaturated components into monounsaturated or polyunsaturated. So let's work with monounsaturated first. Monounsaturated is exactly what it sounds like. It only has 1 carbon-carbon double bond. Okay, we're focusing on the double bond here. Alternatively, you could have something that is called polyunsaturated. Poly, meaning more than 1, okay, and saturated, okay, unsaturated, excuse me, so you have the double bond. So in this one, you have at least 2 carbon-carbon double bonds. At least 2. You can have 3, 4, 5, but you have to have at least 2. All right, so now let's look at some examples of this because that was a lot of terminology and that can get really mind-boggling. So let's pull up some pictures here. So what I have are 3 different types of oils or fats, all right? We haven't really classified that yet, but we're just talking about the thing as a group. So what I have here, this first one is called stearic acid. So it's STEARIC, stearic acid. Now what we're looking at here is I see that everything has all carbon-carbon single bonds, all carbon-carbon. There's not 1 carbon double bond in there. So what that means is this has to be a saturated triglyceride. All right, saturated. Let's look at the second one. The second one I have here is called oleic acid. Now what I see immediately is mostly carbon-carbon single bonds, but right here I see a carbon-carbon double bond. If there's at least 1, and in this example there's only 1, this would be considered a unsaturated triglyceride. Okay, so the one carbon-carbon double bond. That's all that's saying. Mono meaning one, unsaturated implying that there's at least one carbon-carbon double bond. All right, so now let's look at our last one. Let me find my pointer there. Last one. This is called linoleic acid. Okay, so now the first thing I see here is that it's primarily carbon-carbon single bonds, but immediately I identify one carbon-carbon double bond and another one. So we have two carbon-carbon double bonds. This would be considered polyunsaturated. A polyunsaturated triglyceride. So our first one, all carbon-carbon single bonds, saturated. The second one carbon double bond, monounsaturated. The second one, two or more carbon-carbon double bonds, has to be considered polyunsaturated. Very complex. You need to start getting comfortable with looking at these line drawings and being able to pull out key information so that you could automatically look at that and be like, oh, monounsaturated or saturated. Okay, so that's the goal. So now what I'm going to ask you here is a couple questions based on these top two structures. So I want you to compare stearic acid and oleic acid. My first question for you is, number one, is oleic acid a fat or oil? Okay, number two is, we're curious, the same question for stearic acid. Okay, fat or oil? Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. This was challenging, all right? You did not have all the information in order to actually answer this question, all right? The only thing you could have done was Googled their melting point, all right? You had to search for it and figure it out. So for oleic acid, we know that this has a melting point of about 16 degrees Celsius. So what that means is that at 16 degrees Celsius, it turns from a solid to a liquid. So at 25 degrees Celsius, this is definitely going to be in the liquid state, which means this is definitely going to be an oil. Now let's look at stearic acid. Stearic acid has a melting point of 70 degrees Celsius. So at 70 degrees Celsius, it converts from a solid to a liquid. So at 25 degrees Celsius, it is definitely going to be a solid, which means this is definitely going to be a fat. Now, without actually looking up a melting point and using this information, so look at their structures and look at what we just learned, that oleic acid is definitely a liquid, which means it's an oil, where stearic acid is definitely a solid, which means it's a fat. So now using this information, I want you to see if you can actually guess whether this one is going to be a fat or an oil. Okay, question 3, go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. I was asking you to use a little bit of quantitative reasoning here. So there were 2 ways you could have done this. Hopefully what you did is you went back here and said, okay, I'm looking at my saturated fat and I know that it is definitely a solid, so it's a fat, right? It's a solid structure at room temperature. So let's look at our oleic acid. When we look here, we see a carbon-carbon double bond and we see that it's a liquid at room temperature, so it's an oil. So then what we did is we looked at this last one here, okay? So we looked at our linoleic acid. Now, so for this one, what we automatically see is there's 2 carbon-carbon double bonds. So right away you should be thinking this has to be a liquid. We have to be talking about an oil here, and that is absolutely correct. You could have confirmed that by looking up the melting point, and I believe it has a melting point close to -5 degrees Celsius, definitely a liquid at room temperature, so that means it's definitely has to be an oil. Now, what did we just learn here? Basically, let me pull up a chart here. Basically, what we just saw is that anytime you have a saturated fatty acid, your melting point is usually greater than 25 degrees Celsius. So if you're looking at a saturated acid, you're usually looking at something that is solid at room temperature, which means it is considered a fat. However, if you look at something that is considered to be an unsaturated fatty acid, so unsaturated, from here, these have melting points that are less than 25 degrees Celsius. So they are usually liquids at room temperature, so they're oils. So how do we distinguish a fat from an oil? If you're looking at it, so if you're physically using your eyes on the macroscopic level, if it is solid at room temperature, it's a fat. If it's a liquid at room temperature, it's an oil. Very straightforward. Now, if we don't have that macro observation and you just have a micro observation, or you have that chemical structure, you need to look at it and say, Are there any carbon-carbon double bonds? If there's double bonds at all, you're looking at an unsaturated substance, and that's definitely an oil. If there's no carbon-carbon double bonds, then you're looking at something that is likely to be a solid and likely to be a fat. So the last thing I want to do is we're going to continue to build this tree, or this flow chart, essentially, starting with lipids. So let's hear lipids, right? Lipids is your overall class, okay? These are the ones that are insoluble in water. From lipids, we can break it down to triglycerides, right? This has to have 3 ester functional groups. From triglycerides, we can break these apart into either fats or oils. Fats are something that have a melting point that is going to be greater than 25 degrees Celsius. They are solid at room temperature. These are the ones that we say are saturated. And I'm going to add a word here, unhealthy. If we're looking at these 2 pieces of triglycerides, our fats are going to be unhealthy. So our oils are going to be our melting point, or our compounds, our triglycerides that have a melting point that are less than 25 degrees Celsius. So these are liquids at room temperature. We call them unsaturated. This could be either monounsaturated or polyunsaturated. And then the thing we're going to add here now is that these are considered our healthy triglycerides. So in our next video, we're going to actually talk about how that happens. Why is something healthy? Why is something unhealthy? But for now, go through and make sure you can easily classify fats and oils. Go.